Number 4 on worksheet number 4 says a 400-kilogram bomb sitting at rest on a table explodes into 3 pieces. One piece goes off east, one piece goes off south of west, and we don't know the velocity of the third piece. You guys know that what we got to do to start off these questions is draw what we call a situational diagram. Okay, a situational diagram isn't a free body diagram. It's not a vector diagram. It just shows us what's going on here. Okay, so what's going on? What's going on? We got a bomb exploding, one piece going off to the east. We're going to make that piece number 1. It's 150 kilograms, and its velocity is 150 meters per second. Good. Now we got another piece going off south of west. South of west. South and west are down here somewhere. So object number 2 is going to be down here somewhere. Is that 30 degrees going to be labeled right here from the west, or is it going to be labeled right here from the south? When you see something like this, just take your angle and circle the second letter. Okay, circle the of west, circle the west. That means your angle should be measured from that angle or from that direction. So 30 degrees from the west as opposed to 30 degrees from the south. The mass of that is 200, sorry, the speed of that is 200 meters per second. And the mass of that is 100 kilograms. Where do you think the third piece is going to go? We know for sure that third piece is going to go up because we've got a momentum down. We have to counter that with a momentum up. Now, that third piece could go up and left, or it could go up and right. We're not really sure about that, but that's okay. Because even if I have that purple one drawn wrong, it's not the end of the world. It's just there to help us to visualize what's going on. It's the black ones that are the really important ones. Okay. Now, before we try doing any momentum stuff, which we're going to have to do, conservation of momentum in 2 dimensions, x and y components. Before we do that, I want to do what? 5 words. 5-word phrase that all of you are familiar with now, whether you had me last year or not. What's that 5-word phrase? Kinda? I don't like funny angles. So we take that funny angle, this 30 degrees off to the side, and we put it out of its misery there. It's 200 meters per second. The angle is 30 degrees right there, and we're going to label this as x, and we're going to label this as y. Let's find the components there. Cosine 30 degrees is equal to x over 200. Because cosine x is the adjacent side. That gives me 173.205 meters per second for the x component. And then the y component we're going to use sine for. And this one's easy. We end up getting 100 meters per second. Now, I usually box that off, although that's just a thing that I do. You don't have to do that. Just to kind of set it aside, to realize so that I can see that although it forms part of the problem, it's kind of a part of the problem that's not really as much a part of the problem. It's kind of an aside thing, right? Right, Bruce? So, what next? Well, we could redraw this. Sometimes we redraw this with just an X and just a Y. I'm just going to leave it the way it is, and I'll just go back to that other diagram that I have boxed off if I need to later on. Okay, let's break it up into X components and Y components. Let's say for my X component, PI equals PF. We have 0 initial momentum because it's this bomb that's at rest. We have 3 objects after the explosion, M1 V1 F plus M2 V2 F plus M3 V3 F. I think it's number 5 that has equal pieces, and we want equal pieces. We want equal masses, and we want that because it makes life easier when they are the same mass. How come? They'll cancel, right? They're not equal masses here. That's okay. It just means a tiny bit extra work. M1 is 150. V1F is 150. M2 is 100. V2F is what? V2F Okay, object number 2 over here, x component of that velocity. Is it 200? No. What is it? Nathan, what is it? It's 173. But we're going to actually make it negative. How come? How come it's negative 173 as opposed to just 173? Kind of? Because it's going west, going to the left, right? Is that okay? Remember that 200 meters per second, it's dead to us now, right? We took the 200 meters per second over here, out back, put it out of its misery. It's gone. It's dead to us now. We're not going to ever see or deal with that 200 meters per second again. The only numbers that come from that 200 meters per second that we'll deal with are this number and this number. It's all we care about now. So instead of V2F being 200, V2F is, 173.205. Okay, we add that to M3, which is, what was the total mass of this thing? 400 kilograms? I think it's going to be 150 kilograms. 400 minus 150 minus 100 times V3F, and we solve for V3F here. If you can't get this, if you can't follow along on the calculator, just let me know. 150 times 150 plus 100 times negative 173.205. Take that to the other side by subtracting. And we end up getting that, and then we divide that by 150, and we end up getting 34.53. Let me see if that's what I have on my sheet. Yep. Negative 34.53. How's that? We done? Is that my answer? Nope. That's the x component of my answer, right? Now what do I got to do? I got to do the y component, right? Now I don't really have space to do the y component. I'll scroll down here, and I'll just do it kind of in number 5 here. The y component, we'd say pi, this is still part of number 4 though. Pi equals pf, 0 initial momentum equals, what's the momentum of object number 1, y component afterwards? 0, because it's, what's moving, I was going to say it's at rest. It's not at rest, it's moving, but it's moving on the x-axis. So we're going to say it's 0 plus, what do we got here? 100. This is object number 2, 100 kilograms. What's V2F? The y component of object number 2's velocity, Nathan? Real close. Not 100, but Julia? Negative 100 because it's going down. Good? Again, remember that 200 it's gone. Like, it's out of our memory. Right? It's that thing that you saw once and you just never want to deal with again. Just put it out of your memory. We replaced it with 173 and 100. Okay, so we add to this object number 3 times V3F. Solve for V3F here. And this is going to work out to be 66.667. And now comes the easy part. 34.53, 66.667, and our resultant vector speed would be equal to 75.1. And where's my angle? Position 1, 2, or 3? 3, because this is the start of the diagram, right? Theta is equal to the inverse tan function of opposite over adjacent, and that works out to be 62.6 degrees. And that would be north of west. North of west because the angle is measured from the west. So that's my second one listed. Okay? Is that okay? We're getting there, right? It just takes a little bit of practice. Okay, you deal with funny angles and questions become a little bit different. But we're getting there. Okay, number 5 says a bomb sitting at rest on a table explodes into 4 pieces of equal mass. Oh, this is the one. Yeah, this is the one that I like, right? Equal mass, because we know right away the mass is going to end up canceling out. But the downside to it is that I have 4 pieces, so there's a little bit more work that way. Let's draw the situational diagram here. Here's my explosion point. X marks the spot of my explosion point. One piece goes south 55 meters per second. I'm not going to worry about its mass because they're all the same. Second piece goes west at 80 meters per second. Third piece goes west of north. So it's going to go up here somewhere, right? West and north. Where am I going to draw the angle? Down here from the west or right here from the north? Circle that second letter. Where am I going to draw it from? From the north. 30 degrees is measured from the north. And then the fourth piece, I don't know. I'm going to say somewhere up here. I know it's going to go to the right because it has to counter to the left, but I don't know whether it's going to go up or down, but don't worry about that later on. 5 words. Maria? Okay, so let's get rid of it then if you don't like funny angles. Okay, guys, Maria doesn't like that funny angle, so we have to, for Maria, we have to get rid of that funny angle. So there's my 30 degrees. There's my, what was the speed of that? Number 3. 40 meters per second. Okay, there's my 40. This is my X. This is my Y. Cosine 30 degrees is equal to X over 40. Or rearrange it, it looks like this. Gives me, wait, what did I do? I didn't even do that on purpose. That was just a mistake that I made not on purpose. At least I caught it. Which side of the triangle is X? Opposite, so which trig function am I going to use? Not cosine, sine. X is equal to 40 sine 30 degrees. Or sine 30 is equal to X over 40. This gives us 20. And Y is equal to 40 cosine 30 degrees, which ends up being equal to 34.641. Okay, box it off to the side so it's in its own little spot. The only numbers that I'm ever going to use from vector 3 again, not that 40 meters per second, I certainly don't want that, but this 20 meters per second and the 34.6 meters per second, I'm going to use those. I'm going to need those to replace the 40 meters per second. We're going to say 0 initial momentum, right? 0 initial equals 0 for object number 1 because it's all on the y-axis. Is that okay? Object number 2 is negative 80. Isn't it m times negative 80? Same mass, what happens? Cancel. Plus, what do we put in here for V3F, object number 3, X component? What do you got for that one? Yeah. Good, negative 20, right? That 40 meters per second is gone. It's dead to us. So we put in the negative 20 that replaces that. Plus V4F. And that works out to be 100 meters per second. Y component 0 initial equals negative 55 because the first one is 55 down. Second one plus, what's the Y momentum of the second one, Zane? How much of this one is Y component, this 80 meters per second? No, number 2 here. 0, because it's all on the x-axis, right? Okay. let's see here. Maddie, what's the y component of the third one here? Good, 34.641. Not the 40, because we're forgetting about that now. It's gone. Plus V4F. And we solve for V4F there. And it works out to be 20.359. Now it's the easy part, right? Now it's like grade 9 math, where it's Pythagorean theorem, right? You got 100 plus 20.359. Solve for V, solve for theta. V works out to be 102 using the Pythagorean theorem. And theta, drawn from the start, works out to be 11.5 degrees north of east. Right, just double check this north of east thing. East is my second letter. Where am I measuring my angle from? From the east. Okay, so north of east is right. All right, last one, time for number 6. It says a 200 kilogram bomb moving with a velocity of 10 meters per second to the west explodes into 3 pieces. First piece has a mass of this, moving this way, west. Second piece, moving at an angle 30 degrees north of east. What's the velocity of the third piece? Okay, here's my explosion point. The bomb is moving to the west. 10 meters per second. Let's just draw like what happens after right now, okay? The first piece goes to the west at 90. And it is 100 kilograms. The second piece goes north of east. This is north and east, right? Where's my angle, 30 degrees? Measured from the north, or is it measured from the east? Measured from the east, right? Circle that second one, measured from the east, 30 degrees, right there. And its value here is what? 55 kilograms and 55 meters per second. Where's the third piece going to go? We're going to guess down here somewhere. We don't know exactly. Remember, though, this is after the collision takes place. Before the collision takes place, the whole thing is moving at a velocity of 10 meters per second. So what are those 5 words should always come to our mind right now? Remember, we got a few things like this, a couple things like this now, right? Area equals impulse for an F versus T graph that we always just think and do. And whenever we see one of these angles of 30 degrees or anything else, it's not 90, we think, I don't like funny angles. So let's take, the other Maddie doesn't like funny angles either. So, oh, it was Maria last time that didn't like it, wasn't it? Maddie doesn't like funny angles either, so we're going to take that funny angle and get rid of it. Cosine 30 is equal to x over 55. That gives us 47.6314. And sine 30 is equal to y over 55. Which is 27.5. Box it off. Pay attention to this number we're going to care about, this number that we're going to care about, which number is gone, which number is dead to us. The 55 meters per second, right? Okay, it's technically still 55 meters per second, but we don't care anymore. at all about it. X, ooh, I'm not going to, sometimes I take shortcuts and don't write down that stuff, right? But I'm going to write it down this time, okay? Because I'm going to forget something if I don't. M1, sorry, just MVI, because the total initial momentum is one object, equals M1 V1F plus M2 V2F plus M3 V3F. Total mass is what, 200 kilograms? What's V1I? What is it usually in these explosion questions? What's VI? Usually it's 0. What is it this time? -10. Who said -10? Good. -10. Not just 10, -10. M1 is 100. V1F is? V1F? Taylor? V1F, object number 1. X component is? Good. -90 because it's going to the left. Good. M2 is, what is it, 55 kilograms? Times what? 55 meters per second is gone now, right? So what are we going to use here? What are we going to use? For X component of V2? Good. 47.6314 plus object number 3 has a mass of, what's that going to be, 155, 45? 45, is that right? Times V3F. Do we need to go through the steps of solving that, V3F, or are you guys okay on your calculators with that? You guys okay? Do you want me to go through it? Yes? Okay. So let's say 200, left side, 200 times -10 gives me -2000. Now, let's subtract 100 times -90. See what I did there? Okay, it's plus 100 times -90. So I subtracted 100 times -90. The alternative would have been just to add 100 times 90. Let's also subtract, brackets, 55 times 47.6314. That's going to give us everything on the left side now. Divide that by 45 to get rid of what is attached to the V3. And I get 97.3394. Good. All right. Y component. Y component's a little bit shorter. What's the initial Y velocity of this thing? 0. So the initial Y momentum is 0. Object number 1, the final momentum is also 0, right? They're saving quite a bit of work here. Plus object number 2. This is the one here, right, that matters. Object number 2 has a mass of 55 kilograms. Object number 2, Mary. Object number 2 has a final velocity, Y component of? Good. And it's positive because it's going up. Now this one's easier to solve for. V3F works out to be negative 33.611. And then we just combine them. Here's my X. Here's my Y, negative, down. Here's my speed. Position 1, 2, or 3 for my angle. Position 1, 2, or 3. 1, because that's at the start of my diagram. So V works out to be 103. And if you're having trouble getting that 103, let me know. Theta works out to be 19.0 degrees. And that would be 19.0 degrees south and east, right? think it's going to be south of east, but let's just double check that. And is my angle measured from the east? Yeah. Yeah, it's measured from the east, so I was right, it was south of east. There we go. Good. Here we're taking a look at our last example on this type of two-dimensional funny angle collision type stuff. Example number 3 says, a 19.5 kilogram red curling rock heading north at 4.5 collides off-center with another 19.5 kilogram blue curling rock at rest. Now, the red curling rock heads off at 3 meters per second, 30 degrees west of north. Why was it important here that I said the red curling rock collides off-center with the blue curling rock? Yeah. Well, they might not necessarily go in opposite directions. Okay, there's the blue one that's at rest. The red one hits it from below, right, from the south. And what happens? They both probably end up still going to the north, right? But they still stay on one plane, on one dimension, right? But if I hit it off center, you guys have seen something like this before, right? If the red curling rock hits it straight on, they just all keep going this way. But if the red curling rock hits it slightly off, okay, then the blue curling rock is going to go over here, and the red curling rock is going to go over here. Right? So it's important, if we've got an angle that's not 0 or 90, then it's important that we have it off-center collision. We don't know the velocity of the blue curling rock immediately after the collision. What am I kind of excited about in this question? It doesn't take much to get me excited about it. The masses cancel, right? It's curling rocks, the masses are the same, they cancel out. 19.5 kilograms, it's 50 pounds almost, right? That's why, remember we talked about this with impulse, that's why you don't want to stick your foot in front of a curling rock to stop it, because that's a 50-pound rock that's barreling down upon you with quite a bit of momentum, and that's going to experience a certain impulse that when you put your foot in front of it, is spread out over a very short time, which makes the force big, ends up breaking your ankle. All right, what do we got here? Let's draw it out. The red curling rock is heading north at 4.5 meters per second. We'll call that number 1. I'm not even going to label the mass because I know that it's going to end up canceling. So I'll just label the speed here, 4.5 meters per second. The blue curling rock is at rest. Afterwards, the red curling rock goes west of north. So the red guy goes up like this. This is object number 1. The red curling rock goes off this way. West of north at 30 degrees, is it measured from the north, from the west, or is it measured from the north? Measured from the north or from the west? Look, west of north, circle the last one, right? It's measured from the north. So we're going to label that 30 degrees up here. And, well, you can probably make a pretty good prediction where the blue one's going to go. If the red one goes west of north, then the blue one's probably going to go, oops, blue one's probably going to go east of north. We don't know where or what velocity, but. And what are the 5 words of the day here? Okay, I don't like funny angles, so let's take it off and get rid of it. We got this 30-degree angle right here. This is X, this is Y, this is, oh, what was the speed there? 3.0? This is 3.0 meters per second. We're going to say, careful here, because the X component is opposite. It's going to be sine, right? Sine 30 degrees is equal to opposite over 3. (1.5). Y component is the adjacent side. 3 is cosine 30 degrees. That's going to be 2.59808. Well, we don't care about that anymore. Ever again. Look at that 3 meters per second and say to it, I never want to see you again. Okay, we don't deal with that anymore, right? We've already dealt with it. We don't have to deal with it now. We've already dealt with it. Now all we're going to worry about is the 1.5 and the 2.59. Okay, so let's go X and Y components like we do. Okay, don't try to make this just a simple PI equals PF question. It's not that. Okay, you have to make it X and Y, PI equals PF. The initial momentum X component is 0 because it's all on the Y-axis. Masses cancel. V1F would be not 3. We said goodbye. It would be, what is it, Bruce? No, not one. Sorry, it is 1.5, yes. But we're going to make it negative 1.5 because it's to the left. Solve for V2F there, and that is like the world's easiest math problem right here. Okay, solve for V2F, it's going to be positive 1.5. Now the Y component's a little bit more work here. I got to put in a term for that because it's moving now, right? Yeah, right? You good? M1 V1I because object number 1 is moving on the Y-axis plus 0 because object number 2 isn't equals M1 V1F plus M2 V2F. Masses cancel, same mass, 19.5 kilograms. V1I is 4.5 this time, not 0. V1F. Logan, this side of the room's kind of gotten off a little bit with me calling on people here. Logan, what's V1F here? No. What's V1F? Dryden, help me out. Object number one, Y component after the collision. Not 3, right? Because we said goodbye to that 3 meters per second. It's gone. We only care about these ones over to the right. What is it? It's 2.59 meters per second. Good. Plus V2F. The second easiest math question ever. V2F equals negative 2.5. No, oh, wait. It's not quite the second easiest. Okay, the fourth easiest math question ever. 4.5 minus fourth easiest one that I almost made a mistake on just now. 4.5 minus 2.59 gives me about 1.5. What is it exactly? 1 point. Oh, yeah, not 1.5 at all. 1.9019. I take that back. It's not the fourth easiest one ever. It's like the 16th easiest one ever. Okay, so now we got 1.5 to the right, 1.9019 down, and then we just solve for theta, we just solve for V. Sorry, positive? Is that positive? Well, somebody told me it was negative. Who told me it was negative? Okay, well, we'll change it then. Okay, this is going all the way down to like the 35th easiest math question ever. So kind of pathetic that I kept getting the 35th easiest one wrong. But so we got 1.5 to the east, and we got 1.9 this way. Maybe I was just doing that to check, to do a little check on you guys and see who was paying attention, right? Maybe that's what I was doing. Yeah. Okay, so let's figure this out now. V is going to be the square root of that stuff. What do we got? 1.5 squared plus 1.9019 squared. 9019 squared. There you go. Now let's square root that. 2.4. And theta is going to be the inverse tan function. Inverse tan of 1.9019 divided by 1.5. And we get 52 degrees here. And that would be 52 degrees north of east. Just a one little check here, final little check. East from the east. Yeah, my angle's measured from the east, so it is north of east. All right, so here's what I want you to do now for the next 15 minutes or so. Take a look at questions 7 and 8 on your worksheet. Worksheet number 4, same one you've been working on.